Now we get to have some real fun. We're going to take a look at transformations of the sine and cosine function. We're going to start with the easy transformations today, and tomorrow we're going to take a look at what's called a phase shift. So what you see here is a chart setting up the information about the transformations for both sine and cosine. They work similarly. The only thing that's slightly different is the symmetry, and I left that blank, so pull up your vocab sheet so you can fill that in with me. Symmetry, as we talked about for the sine function, is rotational. So for the parent function, it's rotational around the origin. And for the transformations we're going to see today, it's rotational around the origin as well, unless there's a shift. And symmetry for the cosine function, as we saw, is reflectional. And that's across the y-axis. And even if there's a shift, it will still be reflectional across the y-axis. Alright, so the domain for both of them, as we already saw, is all real numbers. No matter what you do to it, transform it, shift it, it will still be all real numbers. The range is minimum, and we're missing the underlines here because it's or equal to, so go ahead and add that to your vocab sheet as well. So the minimum is less than or equal to y, which is less than or equal to the maximum, and the minimum and maximum values are dependent upon the vertical shift, which is the d when you're looking at these equations, and the amplitude. So as the functions get stretched vertically, that will of course change those minimum and maximum values. The period of the function, or how long it takes for the value to come back to where it started, is based on the b value. So once you multiply that x by something, it changes the period of the function. So it will no longer be 2 pi, it will be 2 pi divided by b. The amplitude is the absolute value of a, so if a is negative, there will be a vertical flip for the graph, or a vertical reflection, and the amplitude will be the absolute value of that a value, and the vertical shift, as mentioned, is d. And I already mentioned that reflection. So when you graph transformations, you find 5 key points, and we did these with the parent function, and I kind of pointed them out as the maximum, the minimum, and that middle value of 0. Those were the x-intercepts. So those are the key points that we find within one period of each function as we graph it. So you'll see you've got the parent sine and cosine functions there showing one period of each function. So it's got the intercepts, the maximum, and the minimum pointed out. And as you can see, in one full rotation, you end up with 5 key points for each of those. We're going to start with transformations of the sine function. And one thing that you might want to do is organize the information that the equation is giving you so that you can identify the amplitude, you can identify the period, and you can identify any vertical shift. So the a value, what you're multiplying in front of the function, is what gives us our amplitude. 3 is already positive, so our amplitude is 3. So that will stretch our sine function from a minimum of -3 to a maximum of +3. The b value is what we multiply by the x, so in this case our b value is 2, and the period of the function becomes 2 pi divided by 2, or of course simplifying that to just pi. And the d value in this case, we don't have one, there's no adding or subtracting on the end, so we don't have a vertical shift on this one. So here's how we're going to label this graph. We are going to have our y-axis go from -3 to 3 because of our amplitude. And our x-axis now, what happens with the sine and the cosine function is when the period changes, the key points change, but you're always going to split it into 4. So I'm going to jump back to the parent sine function real quickly. So looking at the parent function, remember when we rotated around the unit circle to find those key points, every time was a quarter turn. We took that full rotation, or the full period of the sine function, and we split it into 4, each of those quarter rotations, and that's how we labeled our x-axis, was with those quarter turns. We're going to do the same thing based on a new period of pi. So we're going to start out, that 4th one will be pi, and this is where you're going to have to think about how to work with fractions. We're going to divide pi into 4. That's an easier one to divide into 4. So we have pi over 4, 2 pi over 4, which is pi over 2, and 3 pi over 4. So those are the new x coordinates, or the new radians, for our modified or our transformed function. And of course, we do those same values in the negative direction. And then you simply plot your maximum, minimum, and intercepts based on your new amplitude and your new period. So for the sine function, you start at the origin. Sine, because there's no reflection, it will go up to its maximum at the first quarter turn, back down to an intercept, down to its minimum at a 3/4 turn, and back up to its starting value or another intercept at the full rotation. And then it does the opposite in the opposite direction. It goes down to its minimum. That's my dog walking across the floor. Back up to its intercept, up to a maximum, and back down to an intercept. And then you just connect your points with a nice smooth curve as well as you can. All right, let's take a look at one more sine function. Again, identifying the a, in this case is -1, so our amplitude is 1. Our b value is 4, so the period of this function will be 2 pi divided by 4, or pi over 2. And the d is 1, so it shifts up 1. So what we're going to do is draw in kind of a new x-axis, and that's where our intercepts will be, is kind of along that imaginary x-axis when we have a vertical shift. And as you can see, I kind of sketched my outline of a graph knowing that we were going to have a vertical shift. So now thinking about the fact that the amplitude is 1, so our parent sine function, similar to this, will go from -1 to 1, but it gets shifted up 1, so now our range will be 0 to 2. And where y equals 1 is kind of our new intercept. So I am just going to label my y-axis up to 2. My period is pi over 2, so that fourth spot on the x-axis will be the full period. We cut that in half, we have pi over 4. Cut that in half again, we have pi over 8. And our 3/4 turn is 3 pi over 8. Remembering how to work with fractions, hopefully you're following how I'm coming up with these values. The hard part is getting your graph labeled. Once it's labeled, you simply plot the maximum, minimum, and intercepts based on what you know about the parent sine and cosine function. So real quickly, I'm going to sketch an imaginary x-axis midway between my max and my min, and that's where my intercept value will go. So I'm going to start at 0 along that imaginary x-axis, and because the sine function normally goes up, but we have a reflection, now I'm going to go down to its minimum, then back up to an intercept, up to its maximum, back down to an intercept. And doing the opposite thing in the opposite direction, I'm going up, back to an intercept, down to its minimum, and back to an intercept.